Welcome to 3D Time, from transportation to physics. My name is Ralph Gilman, and this is Part 8, 6D Spacetime. What we've done is taken an opposite view. We've looked at inverted ratios between space and time. We've considered the independent variable in the denominator and the dependent variable in the numerator and changed them around and defined pace, legerity, momentum, and other variables. We've also inverted quantities, and we defined mass as the inverse of mass. And we've taken the opposite directions of gravity versus levity. And then we've developed a series of videos, first on the pictures of what 3D time looks like and objections to it, and then kinematics of pace, legerity, and expedience. The dynamics brought in VAS, defined momentum and rush, and looked at Newton's laws for 3D time. Then we looked at orbits and defined levitation instead of gravitation for orbits. And finally, relativity. Now let's compare 3D space with 3D time. We looked at 3D space with scalar time and direction that is spatial, and compared that with 3D time with a scalar space and which direction is temporal. We've found that space is relative in 3D space and time is absolute and linear, whereas time is relative in 3D time and space is absolute and linear. And in 3D space, events are ordered by duration in a timeline, whereas in 3D time, events are ordered by distance in a place line. 3D space works well for observation and signal reception, whereas 3D time works well for transportation and signal transmission. So 3D space combines with one dimension of time as 3 plus 1, and one dimension of space plus 3 dimensions of time is sometimes called 1 plus 3. Now, space and time, are they qualitatively different? Well, implicitly Galileo in classical physics says yes, whereas Einstein in modern physics says no, they are not qualitatively different. And science seeks unification. As Minkowski put it, from now on there is a union of the two, of space and time. So 3D space plus one dimension of time have been combined into 4 dimensions of space-time. So can we combine space with 3 dimensions of time? Well, 3 dimensions of space and 3 dimensions of time would become 6 dimensions of space-time. What is 6D spacetime? Well, it's a 6-dimensional geometry or manifold in which points are events. It includes 4D spacetime, which is 3D space in a timeline, as well as 4D time-space, we could call it a 1D place line plus 3D time. Is it a complex 3D spacetime, that is, with complex numbers? That's a good question. What would 6D relativity be? Well, if we look at the invariant interval of relativity, which is a kind of distance or metric, it is defined in terms of differences as a delta or differentials as a d. The 4D invariant interval of relativity is defined as a delta s squared equals a delta c, the speed of light, times time squared, minus delta r, a vector of space, squared. And this is a non-Euclidean space-time. Well, therefore, we could define a 6D invariant interval of a delta s squared equals a delta c times w, the vector of time squared, minus delta r, vector of space squared. Another non-Euclidean space-time, this but of 6 dimensions. In conclusion then, we've looked at 3D time in transportation and in physics, and 3D time combined with space as 3D time with a place line, as well as 6D spacetime of 3D space plus 3D time. And so 3D time is real. This concludes our video series. Thank you.